let's dive in. So we'll go to the screen here, pull up Visual Studio Code, and I've got a very simple example using the MT-Cars data set, which is kind of a very simple data set of miles per gallon performance for cars. Actually, let me pull up the data set here so you can see it. Here we go, MT-Cars. We've got, 32 rows, a number of different models, miles per gallon. The field there is MPG. We're going to use the cylinders field. The weight, I assuming this is logarithmic of something. I don't know. I don't really care for my purposes today, but we're just using this to be able to quickly do some plots and regressions, all right? So what we want to do is we want to write a LaTeX paper analyzing some aspects of what determines a car's miles per gallon. And we're going to have a couple plots, a regression table, and then a little small table just kind of binning by different categories, as well as a number. We're just going to pull some numbers out, like, well, what percentage of cars perform at a certain level? Because these are the kinds of things that a researcher will need to pull out of data and put in a report. Okay, so if I can find the right program here. All right, Visual Studio Code. Good example, bad example. So let's start with a bad example. Now, this may seem contrived, but this is how I think most of us approach research, especially when we get started. We'll have our LaTeX file. Oh, I'm also assuming that we're going to write both a paper and give a slide presentation, right? Because that's what scholars often do. So we have paper.text. If you have not used LaTeX, you might want to go do a little quick reading on that. Basically, it will allow you to sort of insert code to separate out the way you format your paper from the content. You will need to look it up. I'm not going to take time to explain it all, but what we're going to have here is our paper, and we'll have a slideshow using, what's it called, Beamer, also LaTeX, kind of like PowerPoint. And we've got our data set here, a CSV file. Now, notice a few things. Everything is dumped in one big folder, right? Now, let's say that you are coming to this cold. Let's say that you are trying to replicate someone else's research. You might get a zip file containing all of this. And take a look and ask yourself, what are all these things? Which ones are data? Which ones are inputs? Which ones are outputs? Well, presumably, the paper.pdf and the slides.pdf are the final output. You got all those other files that LaTeX generates. We got two different CSV files, MT-Cars with metric. Well, I don't really know what's going on there. It looks like there's more fields in metric. Which one comes first? I don't know. Do I have to go look at like date stamps to try and figure out which is the source? Like, who knows, right? And I often see replication data like this with multiple files that it's really hard to know what's what. There's a picture, a mountain. Okay, I'm going to use that later, but just like a little logo. What's that? Okay, now there's a couple different R files, prepare data set and analysis. Am I supposed to run those? What do those do? There's a PNG file. Okay, well, so we have weight by miles per gallon. Like, now where did this come from? Did they pull this out of someone else's paper to embed? Is this like a footnote, or is this like something the R code generates? It's really hard to know because everything is all slushed together. Now, if you are having to replicate this, you'd probably have to start actually looking at code, trying to figure out what order to run it in, right? So let's go to prepare data set. Okay, I can kind of figure out what's happening. They're loading in mtcars.csv. Sorry, this should actually be like that. It's a leftover from my good example. And they're going to just add some unit conversions and output mtcars. Okay, so already we have this kind of issue where we have a source data set, and then there's manipulation done by the code that creates an output. But because it's all lumped together, you wouldn't really know that, right? You'd have to kind of figure it out. Well, now let's go to analysis. All right, we're using Stargazer, which creates LaTeX regression tables, and Xtable, which creates LaTeX versions of tables. We're using the metric data set here. Okay, so this must happen after prepared data sets. We're going to figure out what proportion of cars get more than 20 miles per gallon. I will interject here and say that I did this MT-Cars conversion to metric just to show the process of how you might need to manipulate data and transform it before you do your analysis. We're not actually going to use those metric fields. But anyway, that's kind of artificiality of the course. Okay, so they printed out what proportion of cars. Now, I don't know what this number is, but I could run this to find out. We're going to run a couple of regression tables, 2 different models. Looks like we're regressing miles per gallon on weight and horsepower. And Stargazer is going to create a regression table with those 2 models. And then we're going to figure out, we're going to group the cars by how many cylinders they have, and then create a table of their average miles per gallon by cylinder. Okay, so that's what that table is. And then we're going to create a plot of miles per gallon by weight. And I don't see anything about saving this. So if that is being used for anything, the author of this might have gone in and manually saved it out of RStudio or something. I don't know. So already we have this confusion of trying to understand what all of this is and the sequence in which it's supposed to flow. Now let's take a look at the paper. So we have some header stuff, title, author. I'm the guilty party here. I wrote the bad paper. Got an introduction. All right, now we get to our analysis. In the MT cars data set, 44 of the cars get at least 20 miles per gallon. Well, where's 44 come from? I don't know. If I go back to the analysis, presumably, okay, there was this number. So hopefully that's 44, right? Well, what happens if something changes? What if someone went back and realized, hey, one of the lines was wrong in the data set, we need to fix it? Well, now maybe this is like 42% of cars get this mileage. The only way you would catch that is if you manually went into this code, reran it, noted the number, and then went back to your paper to check. Okay, I better fix that 44 cars. Now, let's say you're writing a 300-page dissertation full of numbers. What are the odds you're going to be able to go through and find every single one of these, right? Like, your odds of catching everything could be pretty low, particularly if your data is changing a lot or you're finding errors and trying to fix them. Oh, but it gets worse because we also have a slideshow. What if that number is in the slideshow? Okay, so now we're in Beamer. We've got each of these is like a slide, right? Here's our introduction slide. Here it's showing a picture. That's that mountain. It's a little logo. Oh, there it is. All right, in the MT cars data set, 44 of the cars attain at least 20 miles per gallon. All right, so what you're seeing here is there's 3 different sources of truth for the same thing. There's the code, where we get the number, but the paper and the slides, that has to be hand jammed. So we have 3 sources of truth. That should be a red flag. One of the cardinal principles of software engineering is you only want one source of truth. Every other usage of that should be automated. All right, let's keep going. So in the paper, we have that. We have a table, cylinders in average miles per gallon. Okay, if you recall, we saw in our analysis an X table to do just that. Okay, that's probably where that came from. Well, they must have hand copied that output and pasted it into the paper. And also, this has nice column headings, and I put my little notes here. When you run Xtable, unless you manually go in and specify the columns, they're going to come out looking just like X1, X2, the column headers. So when I copied and pasted it, I had to actually go in now and manually edit these to make it look pretty. Well, now if I have to go redo my table because there was a bad data point, I'm going to have to go reformat all this stuff by hand. Now you can start to see the hours accumulating the night before you're due of trying to fix all your broken stuff that you have to redo and redo and redo. This is a terrible place to be, and a place that no good software developer would ever let themselves get to if they can help it. Same thing with the slides. We're going to find this same thing appearing in the slides. So again, 3 sources of truth, the Xtable command, and then 2 copy pastes. We've also got a regression table outputted from our analysis. Here, the Stargazer line creates this table. We've also got three sources of truth. It's in the paper and it's in the slide. And then there's the plot. We were trying to figure out earlier, what is this plot? Well, it is pasted in the paper and it's pasted in the slide. And again, we're not really sure how it got from code to here, but presumably the person who created this hand saved the output of that plot command. So this paper is a train wreck, and this is a short paper. It's only got a few things, and maybe that's okay. If you're doing a course paper, you've only got 1 week to do it, so you're working on it solo, you're never going to look at it again. You can get away with this, but it's still a lot of cognitive stress of worrying about how all these things match up, and there's a very high risk of things falling out of alignment, okay? We can take a look at our paper, the compiled output, demo paper the bad way. There it is, 44 cars. Here's our table, our regression table, and our plot. So it's all in there, done by hand. Slides, very similar. We have our asset, there's our numbers, our table, our regression table, and our plot. Now, if I was to continue working on this, now you start to see, all right, now I'm on version 1, but I'm going to go change some things. I'm going to save this as version 2, right? So I got paper v2.tex or paper version 28.tex. Well, how am I thinking about versioning of that paper versus my code? If I come in here and see all these different versions, what if I see different code versions? Analysis version 1, analysis version 5. How much confidence would you have that every table and figure is properly matching the code versus what you see on the slides? And then, the code here is pretty clean. I left it clean. But in a real project, and you know it, you've done it, you're going to have all kinds of extraneous garbage of trying to make things work and figure out. And these things aren't even necessarily going to be in order. And anyone who's worked in R and probably Python too knows you've got a lot of variables floating around. You could very easily accidentally run things out of order, get wrong results. So this thing is a house of cards. And this is how we usually do it. We're not taught any better.